Hey everybody, your Friendly Math Tutor here with episode 7 of our SAT mini course. Each episode we're going to dive into a specific strategy that you can use on your upcoming SAT. Alright, so let's go over the closer problem from episode 6. This is from College Board Practice Test 8, Section 4, number 17. This is the ages of 20 students enrolled in a college class. So they give us this frequency table. They say which of the following gives the correct order of the mean, median, and mode. So the easiest thing to find in a frequency table is the mode. That is just defined as the number or the data point that shows up the most. And in this case, it's clearly 18 because 6 is the highest of all the frequencies. So our mode must be 18. Now let's quickly figure out the mean. Remembering that the mean is the sum of all the data points divided by the total number, which in this case is 20. And then what we want to do is figure out the total in a really, really quick way, which is just going to be multiplying 6 by 18 because it's really there's 6 18-year-olds, so the sum of their ages is going to be 6 times 18. And then we're just going to add straight across. So we're going to do 5 times 19 plus 4 times 20 plus 2 times 21 plus 1 times 22 plus 1 times 23 plus 1 times 30. All right, for this one, I'm actually going to get out a calculator. So we can add these up, and if you want to do this along with me. So we're just doing 6 times 18 plus 5 times 19 plus 4 times 20 plus 2 times 21 plus 22 plus 23 plus 30. And that gives us a nice easy number of 400. And 400 divided by 20 is simply 20. All right? So we've got our mode of 18, our mean of 20, and then our median. Now, the median is just the middle number. If we have 20 students and we lined up 20 students, you want to picture the student in the middle. Just do 20 divided by 2, which is 10. So the median would be between the 10th person and the 11th person. So we just have to figure out basically which age that would be. Well, the first 6 people are 18 years old, and the next 5 people are 19. Well, look at that. 6 plus 5 is 11, which puts us over our halfway point. So that must be the age of 19. So the median is 19. We do not have to list them out and do the cross-out method. Again, the quickest way to look at this is divide 20 by 2. You get 10 and add these up until which age will put you over 10. 6 plus 5 is 11, so age 19 will put you past the halfway point, so the median must be age 19. And then we simply put them in order. So these are all arranged, these are less than symbols, so they are going from least to greatest. So it's the mode, then the median, then the mean. That is A. All right, so that concludes our work with frequency tables and histograms. And now let's move on to today's topic. All right, now on to today's topic of percentages. So today we are going to speak about this specific topic. There is a strategy involved, but today there's going to be no school way. There are multiple ways to do percentages, and there is the way that I'm showing you is something that's also taught in school. It's taught several ways. I'm just going to show you your Friendly Math Tutor way is what we believe here is the easiest way for you to look at percentages and give you the highest probability of getting these questions correctly on the SAT. So like last week, these are, there's nothing to really look out for. It's going to be really easy to know whether it's a percentage problem or not. You're literally going to see the percentage symbol or the word percentage. And this is what we do today is not going to apply to anything that's not percentages, all right? but it is a pretty important topic that I think it's worthy of it having its own episode. And before we get to the opener problem, with this topic, I am going to do a bit of a mini lesson. So I want to go over a couple things. So let's look at percent decrease. And my example for that is going to be a discount. So you go to the store and you find out that there is a 15% discount. And you want to find the price that you're going to pay. Now let's just say that what you're buying costs $80. And we want to figure out what price would we be paying. Now, the long way would be to actually take 15% of 80, but all that tells us is what our discount is. It doesn't tell us what our final price would be. We'd have to then subtract that, which is a two-step process. So your Friendly Math Tutor way is going to try to do this as a one-step process, to save time. And also, we're going to have to create equations, and the equations are going to be a lot easier if we follow this one-step process. So what I want us to look at is, instead of thinking of it as a 15% discount, that's looking at it from the perspective of what we're not going to be paying, but we're more concerned with when we go up to the cash register, how much are we going to be paying? So if something is a 15% discount, the initial amount that we would pay is the entire price, which is 100%, and we're discounting it 15%. So that means that we are paying 85% of the price. So the number that we should be multiplying by is 0.85. And we would multiply that by 80, and whatever that equals would be the price of the item that we were purchasing. So we want to get used to, when we see a 15% discount, we automatically think of that as 85%, and then we automatically have to go from a percentage to decimal form, which just means we move the decimal over 2 places. So 0.85 is the decimal version of 85%, and anytime we set up equations, we want it in decimal form as opposed to percentage form. All right? So then the second thing we want to take a look at, in order to use the Your Friendly Math Tutor way in our SAT problems today, is we want to look at a percent increase. A percent increase, an example would be sales tax, but there's a lot of different examples for percent increases. So let's say that we buy the same thing and there's no discount this time, and it just cost $80, and the sales tax is, as it is here, we'll say it's 7%. All right. So if we want to increase something by 7%, again, we could take 7% of 80, but all that is the actual tax. It's not our final price. So what we need to do is add that back to the 80. But instead of doing 2 steps, we are going to combine this into 1 step. So again, if we just pay for the item completely, we're paying for 100% of it. But now that we're increasing the price by 7%, that gives us 107%. And if we want to think of that in decimal form, again, we move the decimal over twice. So we would multiply $80 by 1.07. So essentially, anytime you have a percent increase, you are doing 1 point, whatever the percent increase is, or it's really 100 plus the percentage, and then you're moving the decimal over 2 to the left. And if it's a percent decrease or possibly a discount, that's when we would subtract from 100% and use that decimal. Just simply looking at it from that perspective is going to save you a lot of time. So now let's look at it and see how we can actually put that into action on some SAT problems. All right, now to our opener problem. This is College Board Practice Test 10, Section 4, number 12. A book was on sale for 40% off the original price. If the sale price of the book was $18, what was the original price of the book? So it's telling us that it was on sale for 40% off, and what I want you to do is when you see 40%, I want you in your brain automatically to just think, I am going to multiply by 0.6. We get that because it is on sale, so we assume that's a discount. 40% off of 100% means we are paying 60% of it, and 60% as a decimal is 0.6. So this is the number that if you can see 40% off and automatically thinks 0.6, it's going to be really, really beneficial. So now it's pretty easy to set up this equation. It says the sale price of the book was $18. What was the original price? Well, let's say the original price was X, and I'm going to multiply X by the 40% discount, which is really 0.6X, and then after I do that, I end up with $18 as my price. All right. So all I need to do for this one is solve this really straightforward equation, and I get divide by 0.6. All right. And we could probably, again, this is going to be section 4. Most of these problems with percentages, you're going to be using calculators for them. But 18 divided by 0.6 ends up being $30. So 30 would be our answer, which is choice C. All right, so let's move on. All right, so now to our second problem. This one is College Board Practice Test 10, Section 4, number 16. In 2015, the population of City X and City Y were equal. From 2010 to 2015, the population of City X increased by 20%, and the population of City Y decreased by 10%. If the population of City X was 120,000 in 2010, what was the population of City Y in 2010? All right, so that's a lot. That's a lot to kind of digest, but let's just talk about the main points of this problem. So I'd like to look at the end and see what they gave us. They said that the population of City X was 120,000 in 2010. So let's set up an equation for City X. They told us that this was the population in 2010, and they said that in 2015, or from 2010 to 2015, the population of City X increased by 20%. So in 2010, the population was 120,000, and from 2010 to 2015, the population increased by 20%. So it increased, so it was 100% and it increased by 20, so now that's 120%, and as a decimal, that's 1.2. So this is going to give us what the population is for City X in 2015. So that's 120,000 times 1.2, and I get 144,000. All right. So that is the population of City X in 2015. So then it says that City Y decreased by 10%. But let's understand this. This is the population in 2015, and our goal was to find the population back in 2010. So now here's where our variable comes in. So if we look at City Y, all right, I'm just going to use P for population. So this was the population back in 2010. We don't know that. That's what we're looking for. And then it decreased in City Y by 10%. Well, if we start at 100% of the population and we take away 10% of the population, then that means 90% of the population will still remain. So we should multiply by 0.9. So 0.9 is the decimal associated with a 10% decrease. And then we know that 0.9% of the population back in 2010 must equal the population in 2015. But it says that in 2015, the population of City X and City Y were equal. So that's the 144,000 that we found before. So we simply divide by 0.9. So I'll just double check with the calculator. So it's 144,000 divided by 0.9, and we get 160,000. Which is choice C. C. So let's just recap. We took the initial amount of population for city X in 2010 and we multiplied it by 1.2 because 1.2 is what represents a 20% increase. That gave us the population in 2015. Then we went back to city Y and we said, okay, well, there was P number of people, which we don't know, that's what we're looking for in this problem, and 0.9 is associated with a 10% decrease. So 90% of the population back in 2010 should give us the 2015 population, but that's the same as the city X population, which is what they told us here in this first sentence. And just solving that equation pretty simply gives us 160,000 people. All right, so there's a lot going on in there. And also notice this is a problem where we had to read the whole thing. So I know we've had some episodes in the past where I've told you, skip to the question or but we don't see any equations here that are literal equations or slope-intercept form. I don't see any histograms or anything, so there's really no shortcut here as far as reading, which is why you want to take the shortcuts on those other problems and leave yourself some extra time to be able to read a problem like this maybe twice to really get an idea what's going on and to try to set it up in a way that'll allow you to get the answer. And also using these little shortcuts of knowing 20% increase is 1.2, 10% decrease is 0.9. All right, the math behind it is not difficult, but setting it up can be. All right, so let's move on. All right, now to our third problem, College Board Practice Test 9, Section 4, number 38. All right, so we've got this table of values here. This is not a frequency table. It's just a regular table. It says the table shows the number of international tourist arrivals rounded to the nearest tenth of a million to the top 9 tourist destinations in both 2012 and 2013. The number of international tourist arrivals in Russia in 2012 was 13.5% greater than in 2011. The number of international tourist arrivals in Russia was K million more in 2012 than in 2011. What is the value of K to the nearest integer? Oh wow, that's a lot, right? So the reality is much of this is just trying to distract you. All we really care about is in 2012 was 13.5% greater than 2011. So if I look at 2012 in Russia, the only number on this chart that I care about is 24.7 million. I do not care about any of the other countries. They're only talking about Russia, and I only care about 2012 because then it mentions 2011, which isn't even on our chart. So you have all these numbers and it just looks like, oh, this is so much to do. So I would suggest circling the number and then blocking everything else out. So then what I would do is maybe a little bit of work. Our goal is to find 2011 and they gave us 2012. So 2012 was 24.7 and 2011 is what we don't know, which is X. But they did tell us that the 2012 was 13.5% greater than in 2011. Greater, that's a percent increase. So if I add 13.5% to 100%, I get 113.5%. So that's 113.5%. And again, to change it to decimal form, you move the decimal over twice. So I'm going to multiply this by 1.135, and then that's going to equal what it was in 2012. So this will tell me the population, or sorry, it's not population, the number of tourist arrivals in Russia in 2011, which is part of what we need to find in order to actually answer the question. So that means that in order to get X by itself, I would divide by 1.135 on each side. So 24.7 divided by 1.135 is 21.8. And then finally, the question wasn't what the tourist or number of tourist arrivals was in 2011. It says it was K million more in 2012 than 2011. So that just wants us to do 24.7 minus 21.8, which is 2.9. And then it's really important that when you have the grid-ins, you've got 4 spaces, 2.9 would definitely fit, and there's definitely a place to put a decimal, and there's a bubble to fill it in. But this says, what is the value of k to the nearest integer? So that means we should round this to 3. So 3, even though we got 2.9 as our answer, what we would want to do is round it the way that they tell us, and when you fill it in your grid, you would just put 3 and bubble in 3, and then you'd be done. All right, so really important to, anytime you get a decimal, to read, go back and read the last sentence. It'll usually tell you there how you should round. All right. All right, now to our 4th problem. College Board Practice Test 3, Section 4, number 27. A rectangle was altered by increasing its length by 10% and decreasing its width by p%. If these alterations decrease the area of the rectangle by 12%, what is the value of p? So let's first remember we have a rectangle and we're talking about the area. So the area of a rectangle is length times width is the area. And let's go through and kind of manipulate this equation based on what they tell us. So it was altered by increasing its length by 10%. So you should understand by now that if you're increasing something by 10%, that is 110%, because it's 100 plus 10, and then you move the decimal over twice, so that is the decimal 1.10, or just 1.1. So I'm multiplying its length by 1.1. So now I have 1.1L. Then it's decreasing its width by p%. Well, we don't know what the percentage is, so we don't know exactly what decimal we're using. So let's just think of it as, I'm going to put a question mark for a reason. I don't really want to introduce a new variable, but I don't want to use p, because p is the percentage, and that's what we would actually be subtracting from 100. So I really think it's a lot easier just to think of it as, all right, I am going to multiply w by just some number, and I'm just going to call it question mark. If you want to use a different variable, there just seems to be so many variables, and I don't want to use p, because whatever the percent that we're taking off, we've learned earlier, is not the same decimal that we would be using, all right? So I don't want to put a p in there, then solve for p and think that that's the answer. We're going to have to make a small adjustment at the end to actually find the answer, so that'll make more sense when we get to it. Lastly, this results in the area of the rectangle being decreased by 12%. Well, let's think about that. We start at 100%, we take away 12, we are now left with 88% of the area that we had before. So 88% is 0.88 A. So the way this works is essentially, whatever I multiply the length and the width by, if I multiply them together, that has to result in this decimal 0.88. So the variables L, W, and A are actually insignificant, right? We're just multiplying, we just want to figure out what the coefficient is. So 1.1 times some question mark is going to give us 0.88. So that means I just divide by 1.1. So the question mark equals, so let's take a look at 0.88 divided by 1.1. And that is 0.8. Now this is why we're doing this problem last, because this has an added step of, we have to remember before, when we were doing a discount, we would take that percentage away from 100 and then use that decimal. Well, now we're trying to figure out the percentage given the decimal, so we have to work backwards, and we have to look at it like this. Well, first of all, it's 0.8, it's less than 1, so it was definitely a percent decrease. And we know that because it says it was decreased by p%, so that means we're on the right track. Now, specifically how much? So 0.8 is 80%. Well, if we're keeping 80% of it, that means we lost 20%. So see how we're working backwards? Before, when we were given a 20%, we would subtract it from 100 and we would use 0.8 in our equation. Now we have 0.8 as the answer, and we're trying to figure out what was the percent discount. So if we're multiplying by 0.8, 0.8 is 80%, 80% would mean that we took 20% away. So that is a 20% decrease. It's not a discount, we're talking about a rectangle, but it's the same idea. So we're decreasing it by C, 20%. So when you do it this way, you have to remember, when you get a decimal answer, you have to figure out what that actually means in terms of decrease or increase. All right. All right, now to our closer problem. College Board Practice Test 1, Section 4, number 20. Alma bought a laptop computer at a store that gave a 20% discount off its original price. The total amount she paid was P dollars, including an 8% sales tax on the discounted price. Which of the following represents the original price of the computer in terms of P? We have 0.88P, P divided by 0.88, 0.8 times 1.08P, and P divided by 0.8 times 1.08. So just some things to think about. Let's understand that a 20% discount, think about what decimal that represents, and also what an 8% sales tax or 8% increase, what decimal we should use for that. And also make sure that we set up an equation, all right? P is the amount that she paid at the end, and what we're looking for is the original price. So just to make sure, again, what goes with 20%, what decimal, what goes with an 8% increase, what decimal. The answer should have those decimals in there, and then it should be in the correct order based on our equation that we set up, all right? So good luck with that one, and we'll go over that in episode 8. All right, now to today's takeaways. So we talked about percentages, and there was no school way, but we did do, your Friendly Math Tutor way was just this kind of way to look at percentages to allow us to always do them in one step and then insert them into equations, and it makes it a lot easier. So just to recap, let's say we have a 20% discount. We would use 0.8 as our decimal, because that's 80%, and a 20% discount means we're paying 80% of it. Let's say we have a 9% tax. Well, a tax is going to be an increase in price. 9% is 0.09, but we're adding that to 100% or to 1, and we're going to use 1.09 in our equation. Then, let's say we have to work backwards. Let's say we solve an equation and we get the decimal 0.75. We have to know what that means. We might just think, oh, that means 75%, but that's not really what it means. It's less than 1, so it's a discount or a decrease, but it's 25% less than 100%. So this would actually be a 25% decrease. And lastly, let's say you do the math and you end up with a number like 1.13. Well, this means since it's above 1, it must have come from some kind of increase. And specifically, this is like 113%, which is 13% more than 100%. So this is really a 13% increase. So if you understand that, you should have no trouble with a lot of the percentage problems that are on the SAT. And you have to be able to work kind of both ways with it and then set up equations. And solving those equations are usually going to be really, really simple. The hard part is going to be reading. So these are the type where I would read the whole problem. Mark or circle, however you like to do word problems. But these are an example of ones where you are actually going to have to read and you're going to really have to understand, are they giving me the original price or the original amount and then I'm multiplying? Or are they giving me the final, which means I would probably end up dividing to solve the equation. So those things are really important that we understand and we really read. All right, so I think that's it for episode 7. Thank you for watching. Please like us, subscribe to our channel, leave comments, follow us on Instagram, we're on Facebook, and we're on Twitter. And I don't know why I said it that way, but we are on Twitter. And until next time, your Friendly Math Tutor is out. Whoops. Now let's do that over. Let's just start everything over. All right. Never mind. I lost my train of thought.